Have you ever wondered how to measure the quality and performance of your object-oriented software systems? Well, you're not alone. It's here that object-oriented metrics come into play. These metrics, a key part of object-oriented analysis and design, or OOAD, offer a quantitative approach to assess the quality, complexity, maintainability, and performance of object-oriented software systems. They serve as a valuable tool for developers, architects, and project managers, helping them understand the characteristics of their code base and make informed decisions about design, refactoring, and testing. Whether it's focusing on classes, methods, objects, or the relationships among these elements, these metrics give us a clear, data-driven picture of our software's architecture. And in the ever-evolving world of software development, having such insight is not just helpful, it's absolutely vital. Stay tuned as we delve deeper into specific object-oriented metrics and how they can help you. First up, let's explore coupling between objects, or CBO. This metric measures the degree to which one class is dependent on others. In essence, it's a way to quantify the interdependence between classes in your code. Now, why is this important? Well, high coupling suggests a tight interdependence, which can make your code more complex and harder to maintain. Think of it like a tightly knit sweater. If you pull one thread, the entire structure could unravel. On the other hand, low coupling implies that each class can operate independently, which generally simplifies maintenance and enhances readability. It's akin to a basket of apples. Remove one apple, and the rest remain unaffected. So, when considering CBO, you generally want to aim for lower values. This often leads to more flexible and maintainable code. Remember, in the context of CBO, the lower the coupling, the better. Next, we are going to discuss lack of cohesion of methods, or LCOM. This metric is a fascinating one, as it provides a peek into the internal workings of a class. It shines a light on how closely related the methods within a class are, based on the attributes they share. The more a class's methods are interconnected through shared attributes, the lower the LCOM value. This indicates a high degree of cohesion, suggesting that the class has a single well-defined responsibility. Such classes are generally easier to maintain and understand. On the other hand, a high LCOM value signifies low cohesion. This often means that a class has taken on too many unrelated responsibilities. It's a bit like a jack of all trades but master of none situation. Such classes can be difficult to manage and may need refactoring. Remember, higher LCOM suggests low cohesion, indicating that a class might have multiple unrelated responsibilities. Now, let's talk about response for a class, or RFC, and weighted methods per class, or WMC. Response for a class, or RFC, is a metric that counts the number of methods potentially executed in response to a call to a class. This includes not only the methods within the class itself, but also those methods located in other classes that are initial class calls. Imagine you're making a phone call, and instead of reaching just one person, you're dialing into a conference call with several people. That's what it's like when a class has a high RFC. And just like a conference call can get complex and hard to manage, so too can a class with a high RFC. This high complexity is a signal that we might need to consider refactoring our code. Refactoring, if you're not familiar with the term, involves making changes to the code to improve its structure and design, while keeping its functionality the same. It's like rearranging the furniture in your room to make it more functional and aesthetically pleasing, without throwing any of it away. Next, we have weighted methods per class, or WMC. This metric sums the complexities of each method in a class. It's like weighing a suitcase by adding up the weights of each individual item inside it. Just as a heavy suitcase might be a sign that you've packed too much and need to leave some items behind, a high WMC can suggest that a class has too many responsibilities and might need to be broken down. By keeping an eye on these metrics, we can gain valuable insights into our code base. They can guide our refactoring efforts, helping us to improve the design of our classes and make our code more maintainable. Remember, high RFC and WMC don't necessarily mean bad code, but they're like warning signs on the road, telling us to slow down and check if everything's okay. High RFC and WMC can indicate high complexity, suggesting potential refactoring. Moving on, let's discuss depth of inheritance tree, or DIT, and number of children, or NOC. Both of these metrics provide crucial insights into the structure of inheritance within your code base, which can have significant implications for code maintenance. DIT measures how deep a class sits within an inheritance hierarchy. Imagine an inheritance tree, with the root representing a base class and each subsequent level representing a subclass. The DIT of a class is the number of steps from the root to that class. A higher DIT indicates a more complex inheritance structure. This complexity can create a steeper learning curve for new developers and make the code harder to maintain. It may also lead to issues with code reuse, as classes further down the tree may become too specialized. As such, a moderate DIT is generally preferred. On the other hand, NO key represents the number of direct subclasses a class has. In our inheritance tree metaphor, this would be the number of branches coming off a particular node. A high NOC can signify that a class is widely extended and therefore heavily relied upon. This can lead to potential maintenance issues, as changes to this class could have a ripple effect through many subclasses. An overextended inheritance hierarchy can also become difficult to navigate and understand, potentially slowing down development. Therefore, a balanced NOC not too high and not too low is often seen as ideal. Together, DIT and NOC can give us a comprehensive overview of a codebase's inheritance structure. They can highlight complex inheritance hierarchies or heavily extended classes, both of which may require extra attention during code maintenance. By keeping an eye on these metrics, developers can ensure that their code remains manageable and efficient. Understand that these metrics are not hard rules but guides to inform your coding decisions. A balanced DIT and NOC are generally preferred for a manageable and efficient code base. Let's not forget some other key metrics, such as class size, inheritance coupling, and polymorphism factor. Class size is a straightforward metric that measures the number of lines of code, or the number of methods and attributes within a class. Large classes may point to low cohesion or high complexity, suggesting a need for refactoring. Next, inheritance coupling measures the degree to which classes are interdependent through inheritance. High inheritance coupling may lead to issues when making changes in base classes. Lastly, the polymorphism factor quantifies the usage of polymorphism in a code base, such as the number of overridden methods. It can help identify if polymorphism is used effectively or excessively. By keeping an eye on these metrics, you can evaluate the quality and maintainability of your code more effectively. These metrics further contribute to a comprehensive understanding of your object-oriented software systems. Wrapping up, let's look at the benefits of using object-oriented metrics. These metrics serve as a valuable compass, pointing the way to improved software design and performance. First up, these metrics can help identify design issues. For instance, high coupling or low cohesion may indicate a design flaw. A class with a high degree of coupling is dependent on many other classes, making the code more complex and harder to maintain. Similarly, a class with low cohesion may have multiple unrelated responsibilities, signaling that it might be doing too much. Next, object-oriented metrics can guide refactoring efforts. By highlighting areas of high complexity or low cohesion, these metrics can indicate where your code might benefit from a little tidying up. Refactoring or reorganizing your code can greatly enhance its maintainability and performance. Thirdly, these metrics can help improve code quality. By providing objective data on complexity, cohesion, and coupling, they allow developers to monitor and enhance the quality of their code. This can lead to more robust and efficient software systems. Another benefit is the ability to assess maintainability. Object-oriented metrics can give you insights into how easy or difficult it will be to maintain a codebase in the long term. This is crucial for project planning and resource allocation. If a codebase is complex and tightly coupled, it might require more resources for maintenance in the future. Lastly, these metrics can support and streamline testing and debugging. They can help identify areas that are prone to defects or that might need more rigorous testing. This can save time and resources in the testing phase and lead to more reliable software. By understanding and using these metrics, you can significantly enhance the quality and performance of your software systems. Remember, these metrics are tools to help you understand and improve your code. They are not absolute truths, but guides that can help you make informed decisions about design, refactoring, and testing. So don't be afraid to use them to your advantage. They are there to help you create the best software you possibly can.